In this session, we are going to learn about control logic and stateflow. So, it is very important in electromechanical system that we apply the control logic, and with the Simulink stateflow features, we are going to implement this. So, we'll learn what is basically a control logic and how this can be implemented in a Simulink environment using a new feature called stateflow. So what is a control logic? Let me give you an example. An automatic washing machine is going to switch between different operating states. So you must be knowing how does an automatic washing machine works. In an automatic washing machine, you have to simply add your clothes and turn on the supply and select how you want to proceed. So maybe some initial configuration may be required from the user, but afterwards this will be considered as fully automatic. So let us understand what is the meaning of switches between different operating state. So by switches, I mean that it is nothing but changing from one operating state to different operating state. What are the operating states? So let's understand what are the states of a washing machine which is fully automatic. So let's see, the first state is filling the water. So initially the washing machine drum is empty and you have added the clothes, and here the water is going to be filled up. So what is our initial condition? Let's say the supply is available and the clothes are also kept inside, right? And there will be some type of sensors which is going to check out what is the weight of the clothes, and accordingly the medium, high or low duty will be selected. So the first activity, or we can say state, is filling the water. Once the water is filled up and you have added enough of detergent or maybe the washing machine liquid, then the washing is going to get started. Washing is nothing but the washing machine motor is going to run in forward and reverse direction, and the clothes along with the water, they are going to get washed. So once the washing is done, a rinsing activity is going to get started. So rinsing is nothing but to get the water out, and that may involve draining of the water, and the clothes will get dried out. So how the other states are changed? What will happen after the rinsing? So maybe you need to wash your clothes at least in this loop by let's say 2 times. So this is going to be repeated 2 times, and once the rinsing is finished in the second round, the spinning is going to occur. Now the clothes are going to get dry. So for dryer or for drying out the clothes, the spinning is going to occur, and now this may require some hot air or maybe some kind of an heating. So this is the overall control logic of a washing machine. So initially these are all called the states or the operating modes. So if you see, at any point of time in your washing machine, once the supply is on and the clothes are added, till it is not going to get finished, let's say the last state is finish and the initial state is, let's say, the start. So before the start and after the end of finish, we are not going to discuss those situations. So we assume that the start is done and the water is going to get filled. So all these states are followed one after another, and the decisions are made according to what is the condition of washing. And what do you think are those conditions? Yes, washing machine operates on the conditions based on the time delays. So a washing machine, according to the duty, now this duty may be medium or high or low. Now that depends on amount of clothes you are adding. So based on the duty, this delay is selected, and according to this delay in each state. So whenever the state is being changed from filling of the water to the washing, there will be some kind of a delay which will allow the water to be filled to certain level. So once the washing has started, another timer is going to start, and it will, let's say, calculate the 10 minutes. So now once the 10 minute has been finished, the state is going to change after the 10-minute delay, and it will be in the rinsing state. And after the rinsing is done for, let's say, 5 minutes, the water will be filled again and the count is going to increase from 1 to 2, and then the spinning and heating will occur for drying purpose. So this is how an automatic washing machine works. If you have observed, the logic behind the operation is divided into the time delays and the different states. So let us understand what is exactly the control logic by another example. So another example is your car gear system, right? So how do you drive a car which is having a manual transmission system? So initially you have started your car and you will be keeping in a gear, let's say, which is gear number 1, till the speed is above 15 kilometers per hour. And similarly you will keep in gear 2 till the speed is, let's say, 25 kilometers per hour, and you will upshift the gear and it will be, let's say, around 40 kilometers per hour. So these are let's say some of the standard guidelines in order to operate your car efficiently in a typical gear. Now what is the logic over here? So check the speed, what is the value of the speed now, and accordingly this gear positions are going to be chosen from either 1, 2, 3 or 4, 5 and 6. So all these gear positions will be selected based on the sensed value of the speed. And actually it's not just a number, whatever I have written is just a higher number, but it is actually going to be a range. So when your speed is going to fall from below 40, then you need to shift down to second gear, and if the speed falls again below 15, then you need to again shift down to the first gear. So shift up and shift down is called a logic, or they are the important decisions made by the driver. Now what are the standard driving conditions, right? And if you implement this in a kind of a flow chart, then it becomes your control logic for operating or shifting the gears. So shifting a gear is another example of a control logic, where you start your car and let's say the engine is running. Now you have an input which is nothing but a speed over here. Now based on this value of the speed, here is a condition check block, and what is the value of the speed? So is the value of the speed between 10 and 15, then you are going to follow the process 1, or let's say gear 1. If the value of the speed is above 15 and below 25, then probably you will be running your vehicle in the gear 2 by, let's say, process 2. And here you may have a different branches, and you can decide on which gear you want to shift it to. So this flow chart can be actually continuous, where you check the input continuously, right? So it's not going to be a one-time kind of a flow chart where it will start and then its input is detected and the process is done, and that's an end. So it's not going to be end unless and until your engine is stopped. So this is another example of a control logic, where you can implement your logic in terms of a flow chart or core logic. Now this logic may be in terms of your script, right? You may write a C program or a MATLAB script in order to solve this logic. So all this script written is going to be a kind of a language which is a flowchart converted into a C language. Now we are going to learn a different language in the Simulink, where this flowchart or the logic is converted into a state flow. So here we are going to learn about a new technique which is known as a state flow. So state flow is basically a new feature of converting your logic into a systematical arrangement. Let's understand what is a state flow. Before the state flow, we need to actually know what is the state machine. So state flow is a MATLAB Simulink tool where you can implement the state machine. So what is a state? State is nothing but the operating mode of a system. Let's take an example of a car. So this car status, or let's say the operating mode of a car, can be either in the parking mode, the engine is off, or the engine is on and the vehicle is accelerating, or maybe braking, or it's running at a constant speed, or it is the engine is running and it is idle, or it's not moving ahead, maybe at a traffic junction, or you are taking it out from a parking and getting it reversed, or the state of a car may be fueling where it's idle as well as the fuel is added, or it can be another state of the idle category where it is getting repaired in a garage. So these are states of a system, or let's say states of a car. Now state changes based on some decisions, right? So what are those important decisions? So whether you are going from parking to road, or whether there is a traffic or no traffic. And if there is no traffic, probably you may ride at a higher speed and accelerate your vehicle, or you may run at a constant speed. Or if the condition is fuel is going to be near to empty level, then you will go for fueling. So what are the decision making parameters? So decision making parameters may be the traffic, the fuel level, and many other road conditions. So inputs and conditions together are going to decide the state transition. So the state transition is very, very important, where we move from, let's say, accelerating to braking. So accelerating to braking, where the condition may be the traffic is equal to 1. So you have detected the traffic has now arisen, or let's say the situation is such that there is a traffic on the road, and instead of applying the accelerator, you will release it and you will apply the brake. So this is one such situation of the state machine and state transition. So the state machine and the state transition can help us to make a chart in a MATLAB Simulink Stateflow environment. So what is again a state machine? So let's discuss more about it. So here we are considering an event driven system. So basically the state machine implements an event driven system. So the event driven system is nothing but the system which responds to an event by making the transition or the change from one state to another state. So here this transition is going to occur based on the condition, if the condition is going to be true, right? So you will be continuously checking the condition. So here is the logic where if the fuel is empty, right, you will continuously check the fuel level. If the fuel level is below, let's say 10% of the fuel full tank capacity, then this condition is going to be true and the driver is going to search for a gas station or a petrol station. This is called a transition decision making. So the MATLAB Stateflow is such a graphical representation of finite state machine. Now instead of writing a script, maybe in C language or the MATLAB script.m files, you can do this by making some charts like this. So here you have a block 1, here you have a block 2, and you can decide when the event or when the state is going to change from block 1 to 2, or when the state is going to change from block 2 to 3, or maybe again back to block 1. So the MATLAB Stateflow is a graphical representation of your logic. So whatever is your flowchart or whatever is your logic, that can be implemented in a MATLAB Stateflow environment. Now, without discussing more about this, let's take up a untitled file and implement the Stateflow. So here I have a blank model, and we want to actually make a very simple Stateflow arrangement where if the value of an input, then it is going to give us positive 1, and if the value of the input is less than 1, then it is going to give us the negative 1. The example which we are trying to take is based on the input value, right? So we are going to check the input value whether it is less than 0, which is negative, or if it is greater than 0, which is positive. And if such a case is there, then we are going to have the output equals to -1 and if the value is greater than 0, then we have the output equals to +1. So here this is going to be the condition check and this is going to be the output. So how do we implement this in a state machine? So this is going to be the input where the value is going to be continuously checked for this condition. So these are going to be the condition, and we are not going to worry about what if the value is exactly equal to 0, and that can be also implemented as well by adding another state where the output is equal to 0. If the value is equal to 0, the output is equal to 0, or the output is not defined. So we have three things: input, output, condition, and the different states which are high and low. So let us take a blank file. So let me show you how we can actually create a finite state machine in the MATLAB. So here what you see is a chart, and this is how the chart will look like from block point of view. Now once you double click on the chart, it is going to enter into a different domain, right? So whatever you see over here, all these things which are related to this and all this window and maybe other this stuff and this stuff, they are going to change once you enter into the chart mode, because the chart mode is different than the Simulink mode. So chart mode is where you actually create your control logic, whatever you have observed, right? So earlier window was having the white background, and now you have a light yellow background. Apart from that, you also have some symbols coming up over here. So how do we create a chart? To create a chart, first we need to define a state. So in our example, how do we define a state? So let's say there are two states and its name is high, where the value is greater than 0, and here is the state high. And let me take another state where it is low. So these are the two states, and we have named them as high and low. Probably you can name as positive and negative as well. So what we want in this states, that we have to write here, and whatever you see, this arrow is going to be the entry point. So whatever the first state you enter in your chart, that will come with this entry point. And probably you can define an instruction over here, and you may choose to not define as well. What we want when the high state is going to be there. So let's say at the time of entry, and the entry is going to be the keyword, we create an output variable which is value, and we keep the value equals to 1 and a semicolon. So this is going to be a kind of a MATLAB or a C kind of syntax, and you can add it or enter over here itself. Here I am defining the entry point where the value is going to be -1. Now when does the value change from high to low, and what is the error we are getting over here? So here we are getting something called unreachable state. What is the reason behind unreachable state? Because this is going to be there for this state, and which is a default entry point. Now there is no such entry point for this block, and therefore it is showing an error. So how do we define connection of this state and this state? So that can be defined by creating an arrow from this to this. How do you create an arrow? So once you click on the border of a state, here is the border of a state, and from there you will see the symbol has changed to a plus, and then or you can draw an arrow. Now that arrow should be pointing to some other state of your interest. So let's say my condition is the input is less than 0. So if the input is less than 0, the brackets will come automatically, and I just need to now click on the side and my condition is set. So input less than 0, then the high state is going to get changed to the low. Similarly, we need to change it to the low state, changing into high if the input is greater than 0. So if input is greater than 0, then the low state will change it to high. Now, how do we check about the logic? Now, are we clear in syntax? Did we make any mistake? Now, in order to check this, what you have to do simply is click the run button. So when you click the run button, it is going to ask you about unresolved symbols. So here you see there are certain unresolved symbols which are placed in the chart. What are those unresolved symbols? Those unresolved symbols are nothing but input. The MATLAB or the Simulink doesn't know what is an input or where have you declared it, and the other is the value. So let us declare input and value. So how do we declare whatever conditions we have taken? Please remember, we need not to declare the state. The high and the low are two different states, and we need not to declare them because they are not the variables or the symbols. They are just representing the name of a state. In order to declare the value and the input, what we have to do is we need to open up the symbols pane from this option. So here is a symbol pane, and from where you can get it, this is the place where you can get the symbols pane. So in the symbols area, we can actually declare the values and the input. So here comes the value, and it is declared as an undefined symbol. And what we can do is we can actually create it by choosing its type. So we can, what is the value? Value is the output data for us, and therefore out of this all options we are going to select the value as a output data. So this is the output data, and probably now there is no problem. So the now value is declared. We can also create another data, and we can name them as the input can be an input data. So now we have declared two symbols, value and the input over here. And after this, what we need to do is let's come out of this chart and let's see how does the chart look from inside. So let me zoom in, and here is what you see. So you see actually a transparent diagram where what is inside a block represented as a chart. So now whatever is the value, I need to place it as a scope, right? I'm going to connect this as a scope. So let me connect this to the scope, and it's going to display what is the value. And let's connect some input. What kind of input we can connect here? So what is our logic? We can give any random number or any value which is becoming positive and negative. What kind of blocks are coming into your mind? What you will search over here? Maybe a sine wave. Okay, the sine wave will also go positive and negative, or you can use a repeating sequence as well. So let me use a repeating sequence over here which will go positive and negative, and we want to actually analyze both together what is happening with input and output at the same time. So what we want is this value to get changed from 1 and -1 when the input values are greater than 0 and less than 0. So let me set this repeating sequence. So I'm going to set here the timing values which are, let's say, let me define the output values. I want this to go to, let's say, 0 to 20, then again 20 to 0, and then -20, and then again 0. So I have this 5 values at the equal instant of time, and those time instants are, let's say, 0 to 2 seconds, then 4, then 6 and 8. So this means the 0 at the 0 instant the value is 0, at second 2 the value is 20, at second 4 the value is again going to reach down to actually the 0, and you will have finally 0 at the end of 8 seconds. So look at the way which repeating sequence looks like. So this is exactly how the repeating sequence we are giving as input to this block. Now what is going to be the output? What we are expecting in the output? So here this is our input. Let me draw the graph of the input over here, and this is going to be like this, a triangular wave. Maybe one time period is going to look like this, and what is going to be the output? So the value is positive for the entire half cycle. So here the value remains positive for all this duration. So in all this duration, which is from this to this, what we are going to get in the output is positive 1 constant value. So this is a positive 1, and this is going to be 0 and 20, again 0 over here and minus 20 over here. Now what will happen when the value goes negative? So the value is going to be minus 1 for this much duration of time. So this is going to be the output, right? Now probably if you have given a sine wave, then also the output will be similar, right? So what is our control logic? Basically is checking the value positive or negative. So if the value is positive, then answer is positive 1. If the value is negative, answer is negative 1. And this simple logic can be used in many engineering applications. Now let me go back to our untitled file and run this simulation for 20 seconds. Do we have any errors? Probably not. And our simulation is run, and this is what we are getting in the output. So whenever the blue is positive, which is let me show you the legend, the repeating sequence, whenever it's positive, the output is positive. Whenever it goes negative, the output is negative. So this is what we were expecting. And now if you actually wish to get what is happening step by step, then you can see the simulation as well. So you can click on step forward and you can run your simulation in each step. So if I can write, so here comes the high value. In the next step, here is again the high value again, and based on my time step, the value is now getting decreased, right? So now my positive half cycle is coming to an end, and therefore we are going to observe in next few steps the state will change from the high to low. So here comes a 0, now comes the negative, and here what you have seen is the state has changed because this condition has become true, and earlier the high block was active with the blue line. Now the low state is active. So the low state is going to remain active until the value over here goes negative or remains negative, right? So if you click on this, then again now 0, and again the state will be changed. So this is how you can debug your diagram by using the step forward. Let's say we have a traffic light system where it's a crossroad like this. So there is one road going in this direction and another traffic coming in this direction. So this is one road, and similarly the junction is having another road at 90 degree where the traffic goes like this, and the traffic is going to come from top to bottom like this. Now at this junction we are going to have some signals. So here we have the signals, let's say for this passengers or travelers. Here we have another signal and another signal over here and another signal over here. So those riders who are coming over here at this place, they are going to observe this signal. Now these signals, for simplicity, assume only two states, red and green. Now once this is going to be red, all this traffic will be stopped here. Whenever the green signal goes on, the traffic will move. And let's assume for the simplicity there is no right or no left condition. and therefore there are only two possibilities where either this traffic and this traffic will move together on this road, or they will be stopped and this traffic will move forward in this road. So these are the two conditions, and therefore let's say a traffic signal or a traffic light system is implemented in such a way that this becomes green and this also becomes green over here, and this remains green for, let's say, 30 seconds. So 30 seconds this too remains green, and this audience, they will travel or they are going to move. Now after 30 seconds this will go red, and for another 30 seconds this too will remain green. So what is happening actually, at the interval of 30 seconds this green lights are actually changing the state. So here comes the state logic, and here comes a delay of 30 seconds. Now how do we apply the delay in the state flow diagram or a chart? So let me show you the traffic light system in the state flow arrangement. So what you see over here is the north, east, south and west, and there are some indicators. So these are actually the lamp, and which is part of the Simulink library of a dashboard category. So if you go to the Simulink library browser, and if you see over here you will be able to find the dashboard systems and the indicators. So it's actually over here, the dashboard. So when you click on the dashboard, what kind of system you will see? So you will see a kind of graphical user interface. So here comes a lamp, here you have a slider switch for turning it on and off, and here you have probably a gauge. It may indicate the speed of a vehicle, for example, or you have a plot or a number display like this. So these are the dashboard elements which may be very useful when it comes to a graphical user interface in the MATLAB environment. So these are all such lamps, and if I double click on this is a lamp connected to the north signal. And how do we run this simulation? So I'm going to run this simulation for 150 seconds, and let's observe what is happening. So I click on the run, and now there are, let me show you all lights. So here you have north and south becoming green together, and west and east becoming green together. So while the other things are green, the other side is going to be in stop mode, or they will be red. So red indicates the stop state, the green indicates the go state. So the stop and go are provided with a delay. So let's understand how does this chart is built. So I'm going to stop my simulation over here, and I hope you are able to understand what kind of a situation we have created. So I'm stopping my simulation over here. Let me go into this chart and understand how it works. So here U is going to be our default input, and there are north, east, south and west, 4 different states. So Y, Z, R and X are actually those variables which represents dashboard lights. Now what is that condition we are checking in? Are we observing the traffic? No, probably our traffic light system is delay driven, so it's fixed after every 20 seconds. In the previous example I told you about 30 seconds, but we can consider any different second. So after 20 seconds is the condition which we have given over here. So no matter whether this state is going to be true or false, after 20 seconds it is going to come to this state, and after 40 seconds it will come to the next state, and after another 20 seconds it will come to this state where we are changing all those values of red and green lights. So probably we have 8 number of red and green lights and different states. So instead of changing its color of a same lamp, which is a case of a reality in real situation, probably you also have different lights, right? So in a traffic junction, you have a different lights for green and a red. So we have total 8 number of lights and they are operated together. So this is how it is implemented. So the only new thing over here in this state flow is the delay. So now this delay is going to be according to the starting. So after 20 second is going to be the case when the simulation has started. So after 40 second, which means that the 20 second different from the N2 state. Now what will happen once the all traffic from north to south and east to west has been finished? So now you have to repeat it. So this repeat is through this condition. And what is this point? Because it was difficult to connect this arrow to the very first state, which is N1, we have created a junction, and you can find out a junction over here. So this is a junction where you can actually change, or you can use a routing of a signal which represents a condition. Because we haven't provided any condition over here, it is going to follow the same condition which is after 160 seconds. So this is how a traffic light system works. Now you have got enough idea about how the state flow works. Thank you.